Today we're going to be talking about oblique triangles. So what is an oblique triangle? Oblique triangle is a triangle that does not contain a right angle. So everything that you've learned about right triangles go out the window with oblique triangles. So an oblique triangle will either have 3 acute angles or 2 acute angles and 1 obtuse angle. So you can label each angle as uppercase A, B, and C. And the opposite side as lowercase a, B, and C. So there's basically 2 separate rules that we can apply when we're working with oblique triangles. They're going to be the law of sine and the law of cosine. And that's going to be based on the information that you're given. Just A over sine A is equal to B over sine B, which is equal to C over sine C. And the ratio of the length of the side of any triangle to the sine of the angle opposite that side is the same for all 3 triangles of the triangle. So let's take a look at some examples. The first one we could look at is solving each side angle triangle using the law of sines. So the example that's given in the book, they have the following triangle: angle B, angle C, and they have A as 46 degrees, B as 63 degrees, and then, whoops, got my triangles wrong here, so let's redo that. So we have B over here, C of 63 degrees, and then we don't have anything for B. And then we have sides A, B, and C. C is equal to 56 inches. So as you can see, we have 2 angles given. We have information for angle A, information for angle C, and then we have side C given, and that is why we have a side angle triangle. So basically from here, with the information that's given, we can figure out what our angle B is, so we can solve for B here. So what we're going to do is we're going to, we know that a triangle, when you add them all together, you get 180 degrees of the interior angles. So we have A plus B plus C is equal to 180 degrees, and then we just plug in the numbers. We have 46 plus B plus 56 is equal to 180. We can solve from there, which B gives us 71 degrees. And then from here, we can start using, we have more information to solve the problem. So we can start using the law of sine. So as you can see, we have angle A is equal to 46 degrees, angle C, which is equal to 63 degrees, angle B, which is equal to 71 degrees, and then we have side C, which is equal to 56 56 inches. So from here, we have information for both angle C and side C, so we can use that to figure out what side A and side B are. So now we turn over to the law of sines, and we have, let's solve for side A first. So we have A over sine A is equal to C over sine C. So now we're just plugging in numbers, and we have A over sine of 46, which is equal to C, which is equal to 56 over sine of 63. So now we can just multiply sine of 46 by both sides, which gives us A of 56 times sine of 56 over sine of 63. We punch that into our scientific calculator. We're going to get this is going to be sine of 46 over sine of 63. And that's going to give us 45.2. So we know side A is going to be 45.2. And now we can use the same formula to get our B value over here. So we have B over sine B is equal to C over sine C. And we'll plug in numbers again. We'll get sine of 71 degrees is equal to 56 over sine of 63. So now we're just going to multiply both sides by sine of 71 over sine of 63. And that's going to get us 59.4. So B is equal to 59.4. And now we have values for each side, A, B, and C. And we have values for all three angles as well. And that is how we use the law of sine to solve a triangle. However, this only applies if the triangle is side angle angle or angle side angle. If we have a side angle, it's a lot more complicated. So for side angles, when we crunch our numbers, we can either end up with one triangle, one right triangle, no triangle at all, or two triangles. So if we have one triangle, it'll end up looking something like this. A, B, A, and we'll get height is equal to B sine of A. So A is greater than H and A is greater than B, and one triangle is formed. We might have one right triangle where we have A, B, A, and our height is equal to B sine A, and our A value is equal to H, and it is just the right length to form a right triangle here. We might get no triangles where it looks something like this. where A is less than H and it's not enough to form the triangle. Or we might even be able to get two triangles where A is greater than H and A is less than B, and this is when two distinct triangles are formed. And basically the law of sine will determine the number of triangles, if any, and gives a solution for each triangle. And that is pretty much the law of sines. We might want to know what the area of an oblique triangle is going to be. And the formula is going to be area is equal to 1/2 BC times sine of A, which is equal to 1/2 AB times sine of C, which is equal to 1/2 AC times sine of B. So the example that's given in the book, they have A, B, C with an angle of 62 degrees here. B is equal to 10 meters. C is equal to 24 meters. And from here, what we're going to do is we're just going to use using this equation here. So we get 1/2 times B, which is 10, times C, which is 24, times sine of 62. If we punch that into our calculator, we get 105.95, which we can round up to 106. So the area for this triangle is approximately 106 square meters.